So max or min problems. The vertex of a parabola is either the maximum or minimum value. We will use some examples of relationships to show the importance of this value. So example 1, a rocket is fired down a practice range. The height in meters after t seconds is given by the following functions. Again, we have standard form and we have vertex form. The graph of the model is given. We're going to answer these questions strictly using the graph. So state the maximum height reached by the rocket. So let's take a look. We see that the vertex is here, which occurs at 6. So that's 16, 17. So the vertex here is 6, 17. So what is the maximum height reached by the rocket? Well, if we take a look at our vertex, it's 17. Now, there's something that I should have done earlier, because now I'm looking at the 17 and I'm like, what exactly is the context behind this number? So when you're approaching a word problem, again, don't forget to define the variables for yourself. So in this case, the independent, or the x, is actually time, which is t in seconds. And the dependent, or the y, is height, which is h in meters. So I said that this was my vertex, and I looked at it and I said my maximum value is 17. Remember, our y-axis represents height here, so this must represent 17 meters. How long did it take to reach this height? So to reach that height of 17 meters, well, it took us 6 seconds, again, shown to us by the vertex. So we know that the value is 6, but again, that x value represents time in seconds, so it's 6 seconds. In other words, 6 seconds after the rocket was fired, it reached its maximum height of 17 meters. And finally, it says, how high off the ground was the rocket when it was launched? So this seems like a question where they're giving us one variable, we want to figure out the other. So what have they given us? And what are we required to find? How high off the ground was the rocket when it was launched? So we're trying to figure out height. So the required is height. And so they should have given us a time. Again, they didn't explicitly give us a time, but it said how high above the ground was the rocket when it was launched. So when it was launched, right when it was launched, would have been 0 seconds. So this would have been the height of the rocket as soon as it was launched. And then after it was launched, it made this particular trajectory. So if we just go strictly based on our graph, we can see that at 0 seconds, the height was 8. Again, meters, because that's the unit we're given. Something I do want to clarify with this graph. This is the graph of this entire parabola, but we can't use the entire graph to model our situation. Let's think about why. Our x-axis here represents time, which is t, and this represents height above the ground, and that's h. So we already talked about this earlier. Time cannot be negative. The time of 0 is when the rocket was first fired, and then it eventually flew higher up into the air and then dropped down. So what that means is we cannot have negative t values. So all of this is meaningless, because if I say at time is equal to -1, the height is around 7, that has no context for us. Similarly, the height above the ground, when we're at 0 meters above the ground, that means we've hit the ground. And we're going to assume that there's no holes or anything like that in the ground, but the ball can't continue going deeper into the ground. Once the ball hits the ground, it's hit the ground. So even though this entire parabola represents this particular function, this is the only section of the parabola that is relevant to this context. So why did I ask you these questions? So let's just summarize. It's because the vertex is what gave us that information. The vertex here is 6, 17. Remember, look at the vertex with a context. The 6 represents the x variable, which is time. So the vertex actually is 6 seconds. And the y here represents height in meters. So 6 seconds, comma 17 meters. In other words, our vertex occurs at 6 seconds, 17 meters. So our maximum height is 17 meters, and that maximum height occurs at 6 seconds. So that's the important information that the vertex is giving us. So that was a bit easy because they gave us a graph, but even if we do not have the graph, we should be able to answer the same questions using the equation itself. It's a little harder to do to use the equation instead of a graph, but we have the algebraic skills to do so, and that's what we reviewed at the beginning of this lesson. So let's answer the same questions algebraically. The two equations we were given in the question were this and this. Whenever we are asked to find a maximum or minimum value, we need to find the vertex of the parabola. Sometimes they'll say find the maximum value. Sometimes they may use words like find the greatest value or find the largest value, something along those lines. Similarly, instead of stating minimum, they might say find the lowest value or find the smallest value, etc. So look for these keywords. When you have greatest or largest or maximum, you know you need a vertex, or if they say smallest or lowest or minimum, again, you need the vertex. So let's take a look at this particular equation. So this particular function is height is -1/4 t minus 6 squared plus 17. So the vertex of this parabola, again, I take the opposite of the h, so +6 and 17. This means, again, we have to add context. This represents time, so at 6 seconds, the rocket reaches a blank value of 17 meters. So the vertex itself will tell us if it's what time, so in this case, the time and the height, because that's the context behind this situation. To determine if this is the maximum or minimum height, we need to look at our equation. So the a value here is negative, which means it's opening down, which means we're going to have a maximum value here. So the vertex of this parabola is 617. This means that at 6 seconds, the rocket reaches a maximum height of 17 meters. Therefore, the vertex always provides two pieces of information. So based on this, state the maximum height reached by the rocket. Again, the y value represents height, so the y value of the vertex represents our height. How many seconds did it take to reach this maximum height? Well, we said to get to this maximum value, we have 6 as our t, so 6 seconds. And how high off the ground was the rocket when it was first launched? So let's take a look here. So again, we want to find the height. So we'll write our given and required. So the required is the height. That's what we want to find. And the given, when it was first launched. As I mentioned on the previous page, when the rocket is first launched, that's when time is equal to 0. So this isn't a question where you have one of the variables, you want the second one, so just plug it into the formula. Again, there are two options here. There's nothing that says we need to use vertex form here because there's nothing about the maximum or the minimum. So you can use any one of these formulas. I'm going to go with the vertex one. Okay, so we were told that our time is 0. So we have -1/4 0 minus 6 squared plus 17. So that gives us -1/4. 0 minus 6 is just -6, and -6 squared is +36 plus 17. -36 divided by 4 is -9 plus 17, and 17 minus 9, 8. Again, don't forget the units, 8 meters. Now, you should have noticed that I made a mistake in every single one of these questions. And you should have picked up on the fact that I should be writing sentences to answer these questions because they are word problems. So you should say something like the maximum height of the rocket is 17 meters. And then for this question, it says how many seconds did it take to reach the maximum height? It took 6 seconds to reach the maximum height. And this question was, how high off the ground was the rocket when it was first launched? The rocket was 8 meters off the ground when it was first launched. Again, don't forget to write sentences for all of these questions because they are word problems. So far, all the questions we've seen were something to do with height and time. We're going to start a new type of question here, but it works in the exact same way. So here it says, the profit of a shoe company is modeled by the quadratic function P is equal to -5 x minus 4 squared plus 45, where x represents the number of pair of shoes in hundreds, and P is the profit in thousands of dollars. Again, new situation. What I always want you to do is define those variables for you. Yes, it's written there, but I want you to write it out yourself so that you know what you're talking about. So let's start with our independent. Our independent variable is our x, and in this context, the x represents the number of pairs of shoes produced in hundreds. So number of pairs of shoes in hundreds. What does in hundreds mean? So let's say that I say x is equal to 1. That doesn't mean I produced 1 shoes. It's in hundreds, so I produced 100 pair of shoes. Similarly, if x is equal to 3, so this is 100 pair of shoes. Similarly, if x is equal to 3, it doesn't mean I produce 3 pairs of shoes. It means I produce 300 pairs of shoes, so 300 pair of shoes. Similarly, if x is 10, it means I produced 10 hundreds, which is the same thing as 1,000 pair of shoes. So you do always need to look at that unit because in this case, it matters. Or in every case, it matters. Then we have dependent. The dependent variable is our y. And I'm going to write it here. Here it says it's the profit in thousands of dollars. So it's profit, it's labeled with a P, and that's in thousands. So similar situation. If I say the P is 2, that doesn't mean the profit was, thousands of dollars. If I say the P is 2, that doesn't mean the profit is $2. It means it's 2,000 or $2,000 of profit. Similarly, if I say the P is 50, that means I have 50,000 of dollars or $50,000. So keep that in mind. Even though we're putting in nice numbers, so 1, 3, and 10, they actually have a different context based on this question. So let's look at the question. It says, how many pairs of shoes will the company need to maximize their profit? Key word here is maximize. This reminds us of maximum, which reminds us that we need a vertex. So let's take a look at this vertex. It's given to us in vertex form. Great, we can read the vertex right off. So the vertex here is, again, I take the opposite of this, so it's going to be +4, and I take the 45. But just like before, this vertex is meaningless unless I put a context behind it. So the 4 represents, that's the x value, that's the number of shoes, pairs of shoes produced in hundreds. So number of pairs of shoes in hundreds. And this represents the y variable, the profit in thousands. So profit in thousands. So the question is, how many pairs of shoes will the company need to produce to maximize the profit? Well, we know this is the maximum profit because that's the maximum value, and this represents the number of pairs that must be sold to reach that maximum. Again, be careful. Even though our value here is 4, it's number of pairs of shoes in hundreds. So even though X is 4, we know that this translates to 400 pairs of shoes. Okay, so again, exactly what we did up here. The X represents a number, but the unit represents hundreds of that number. So if it's 4, we've produced 400 shoes. Again, don't forget to write the sentence. So the company needs to produce 400 shoes, or 400 pairs of shoes, to maximize their profit. Part B says, what would their maximum profit be if they produce the number of shoes from part A? Again, we see the word maximum. We're told and convinced that we're going to use the vertex. We've already seen this. Well, from the vertex, we know that the y represents our maximum profit. So we know that our y is equal to 45. But again, don't forget the context. It's not just 45. This represents the profit in thousands. So even though the y is 45, this represents a profit of 45,000 or 45,000. So the profit here is $45,000. So the profit will be $45,000. So again, going back to what we said earlier, the vertex does really give you 2 pieces of information. Here we had 4 and 45. The X represented the number of pairs in shoes in hundreds that must be produced to get to the maximum. And the 45, the profit in thousands, represented the maximum. Just like in the previous question where the 17 meters represented the maximum height, but the 6 represented the time to get to that maximum height. We're going to do one last example. So example 3, the Wheelie Fast company makes custom skateboards for professional riders. The company models its profits with the following function, where B is the number of skateboards produced in thousands, and P is the company's profits in thousands as well. Again, start by defining those variables. So we have our independent, which is our X, and in this case, it's represented with B, which represents number of skateboards produced. But again, we have that caveat, it's in thousands. So the number that you get as your X doesn't really represent the thousands. You need to multiply that out yourself. And we also have our dependent variable, which is our Y. In this case, it's P again, which is profit. But again, it's in thousands. It's not the number you see within the actual equation. So we have the Wheelie company, we have this. Okay, let's take a look at that first question. It says, how many skateboards does Wheelie Fast Co. need to maximize their profit? Ding, ding, ding. We see that word again, maximize. We know that we need the vertex. So we're like, okay, we need the vertex. Let me go look at the equation. This should be easy. And then you look at the equation and they forgot to give you vertex form. So now you're disappointed, but you're like, okay, what can I do? And then you're like, wait a second, I have the tools. This is just standard form. To get to vertex form, I'm just going to complete the square. So P is equal to negative 2B squared plus 16B minus 20. Again, this is in standard form. To get to vertex, I need to complete the square. So completing the square, again, we'll do the entire process, factor out the A value from only the first 2 terms. So negative 2 times B squared will get me negative 2B squared. And negative 2 times what gets me to 16B? Again, be careful. So to get to 16b from 2, I need 8b, but you need to watch the signs. I have a negative here. To get to a positive, I need this to be a negative as well. Then you leave some space and copy down the c to the side. The next step is to find that b over 2 squared value. So the new b here is negative. Oh, and it's confusing because the variables are b2, but the a is still here, the b is still this, and the c is still this. So the b value here is negative 8. So negative 8 over 2 squared. That's just negative 4 squared, which is 16. So I'm going to add 16 and subtract 16. You'll notice I'm going much more quickly than I did in the past because you should know this. Again, these first three things I want to keep in my bracket. So I keep it there. I don't want the negative 16, but to take it out of the bracket, I need to multiply it out by the a value. So negative 2 times negative 16 is just positive 32, and copy down the negative 20. Then in the last step, I need to do two things. So again, I need to factor this out and add the last two terms. So this is just positive 12. When I factor this, it's b 16 is 4 times 4. And then I'll notice that a negative works. So negative 2, b minus 4 squared plus 12. Now I have my equation in vertex form. So let me read the vertex. The vertex, again, I take the opposite of this, so 4 and 12. Again, this vertex is useless until I put a context. So the 4 represents number of skateboards, but in thousands. And this 12 represents profit again, but again in thousands. So the question asked, how many skateboards do they need to sell to maximize their profit? Well, when I look at the vertex, I know my X, or my B in this case, is 4, but that represents skateboards in the thousands. So that means that they need to sell 4,000 skateboards. So Wheelie Fast Co. must sell 4,000 skateboards to maximize their profit. Again, the reason I got to that is because when I take a look at my vertex, the number of skateboards is represented by my independent variable, which is 4 in this case. So it seems as though the number of skateboards they need to sell is 4, but the units they gave us was in the thousands. So I'm actually selling 4,000 of skateboard, which is really just 4,000 skateboards. Next, it says, what would their maximum profit be if they produce the number of skateboards in part A? So again, it's maximum. We're still talking about the vertex. So the profit is represented by the y, or dependent variable, which in this case is 12. But again, it's not just $12 profit, it's profit in thousands of dollars. So that means I have 12,000 or $12,000. So $12,000. And so the maximum profit would be $12,000. So with the vertex questions, I think these questions are a bit easier because you know that as soon as you see those words maximum or minimum, you just have to get your equation into vertex form and interpret the vertex. So for homework, again, there's a lot of homework here. I'm going to simplify your life again. You're going to cross out all of these things. I want you to do handout D, which has 3 questions. You need to submit those 3 questions to me. Okay? So thank you, and we're ready to move on to our next unit after this.